Okay. Okay. So let's start. Uh, so in first segment of the lecture video 1 of week 3, the topic was Newton's law of motions, basically first law, second law, and third law. Then second part of the video was about uh, application of the Newton's second law, basically drawing the free body diagram and solving the problem. And last part was about some practice problem about frictional force. Okay, so first thing is that uh, first law, okay, Newton's first law of motion, first law, and then second law, and last one is third law. Okay, third law. And from first law we can describe force, and also inertia. So do you have any idea about the force and inertia? What is force and what is inertia, or definition of the force or inertia? uh, or what is the statement of the first law, Newton's first law? Okay, so Newton's first law state that if there is no external force is applied on a system, then the motion of the system will remain same. So if we consider there is an object in a surface, or in a horizontal surface, then in that case, if the velocity of that object initially is 0, then we can say the object is in stationary state. So in that case, if there is no external force is applied on that object, then the motion of that object will remain same. That mainly the velocity of that object will remain 0, and the object will remain stationary. But if the object is moving with velocity say v equal to 2 meter per second, and the surface is not frictional, so this is a frictionless surface, and there is no external forces applied on the object, then the motion of that object will remain same. That means the velocity will remain 2 meter per second. Okay, so this is the mainly explanation of the first law. Okay, now the definition of the force is basically, from first law we know that the motion of an object will change by a quantity or by a particular thing which is called force. Okay, so force is a particular properties or particular quantity that just increase or decrease the velocity or change the motion of an object, or particularly create the acceleration, because we know that change in velocity is the acceleration. Okay, so this is force, and the unit of the force is Newton. Okay, unit of the force is Newton. And then inertia, so inertia is also related with the force. So initially if the object is stationary state, so in that case we can say there is no inertia. Okay, but if we applied a force on that object, either rightward or leftward, in that case there is a resistance produced which basically prevent the object to move any direction. So this resistance is called the inertia. Okay, so inertia is basically the opposition of the force. Okay, and is the we can measure the inertia by the mass of an object. Okay, okay, so if the mass is higher, then inertia will be also higher. If mass is lower, then inertia will be lower. Okay, so this is the mainly the explanation of the first law, and we can describe inertia and force from the first law. Okay, so I think this part is clear to you, what is force and what is inertia and what is the mainly first law of Newton's first law. Okay, so now second law, Newton's second law. So Newton's second law is about momentum and also force related thing. So the statement is, if the rate of change of momentum, the rate of change of momentum of a system is proportional to the applied force, and the action really occur in the same direction of the applied force. So in that case, momentum. So what is momentum? Okay. Momentum. So momentum is basically mass multiplied by the velocity. So product of the mass and velocity is called the momentum. So the velocity may be initial velocity or final velocity. Okay, so in that case, momentum, if we consider initial velocity, then momentum will be initial momentum, and if we consider final velocity, it will be final momentum. So basically, the momentum change, the rate of change of momentum, then we can say the rate of change of momentum is basically d dt. This is consider the time rate. mv, which describe the rate of change of momentum. This part is proportional to the applied force according to the Newton's second law. Then we can say the mass here is constant, so m dvy dt is equal to, there is a proportionality constant which is k f. Okay, now if we use the unit of the force is 1 newton, mass is 1 kg, and velocity is 1 meter per second, then we can say k is equal to 1. Okay, experimentally prove that k equal to 1, then the equation will be like that: m dv by dt is the acceleration, a equal to f. So finally you can say f is equal to ma. This is the second law. Now tell me, force and acceleration is a vector quantity or scalar quantity? Acceleration and force?
So acceleration is the vector quantity.
Yes, force is also a vector quantity. So in that case, if we write down the correct form of this equation, we have to write down the equation like that: f is equal to m a. So f vector is equal to m a vector. So this is the correct form. Now if more than one force involved, then what will be the equation? So here considering only single force. Okay, if more than one force involved, then the equation will be like that: vector form of the net force acting on an object or on a system must be equal to m a. So this net force means the resultant force basically. So in case of vector, we know that resultant means the addition or particular thing. So if the force, say there is a force acting rightward which is f1, and another force is acting leftward, so in that case they are opposite direction. So if the resultant force or net force will be like that: f1 minus f2 or f2 minus f1. Okay, f1 minus f2 or f2 minus f1. So this will be the resultant force. So basically the net force, vector net force, is equal to ma. So this is the equation for Newton's second law. And another thing is here, you can write down this equation like that. You can write down this equation like that. Basically in your lecture video, equation is described by mainly by this equation like that: if net force along the x-axis into I plus if net force along the y-axis into j plus f net force in case of three-dimensional. Okay, k is equal to m is constant, then axi plus ayj plus azk. Okay, so this is the equation basically described in lecture video, but here in my discussion I will take the equation separately, because we know that we can, if this equation, there is an equal sign, if this equation is satisfied, then we can say this part must be equal to this part, and again this part must be equal to m and ay, multiplication of m ay, and this part must be equal to m into az. So I will explain like that. Net force along the x-axis is equal to max, which is the component along the x-axis of that equation, equation number 1, and again along the y-axis the component of that equation will be like that. If net force along the y-axis is equal to may, question number 2, consider question number 2, and if net force along the z-axis is equal to maz. Okay, question number 3. So here we will discuss maximum time. Equation will be like two-dimensional. Okay, so mainly this is for your information. Just the equation, if we consider three-dimensional, then equation will be like that. Okay, so in maximum case we will use two-dimensional case. Okay, so this is a procedure. So you can use this type of equation, or you can write down the separate equation like that. Okay, so this is the main second law, procedure of the second law. Sorry. Now let's talk about the third law. So the statement of the third law is every action has an equal and opposite reaction. So if we consider there is an object here, okay, there is an object here, and another object is attached with that object, and if you consider this is m1 and this is m2, in that case, if the action given by the m1 object on m2 is along that direction, this is f21, and the reaction given by the m2 object will be like that along that direction, which is f12. Okay, and in that case we can say f12 must be equal to f21, but they are in opposite sign. So this every action has an opposite, negative sign describe opposite, and equal reaction. So every action has an equal and opposite reaction. In that case we can say these two forces are called pair force. Okay, so in case of mainly Newton, it is also say Newton's third law pair. Okay, so Newton's third law pair. And again, we know that if there is an object in a surface, there is no external forces involved, then in that case, weight is downward, okay, and normal force is upward. So in that case, normal force and weight are equal, but there is a negative sign. So these two forces are called Newton's third law pair, normal force and weight. And in maximum case, normal force and weight are equal, but if there is external forces involved like that, in that case normal force and weight are not equal, because there is a component of this force along that direction. Okay, so this is the mainly procedure of mainly this description of the first law, second law, and third law. Okay, so I think this part is clear to you. Then next part is force free body diagram. Force free body diagram. Okay, so if we try to give the definition or explanation of this diagram, we can say that like that the diagram which describe the forces with component in particular direction or in coordinate system is called the free body diagram. And free body diagram basically will be individual diagram for individual object. So before going to the to draw the free body diagram, we have to know about some forces. First is weight, yeah, weight, or we can say this is gravitational force. Okay, gravitational force, basically force due to gravity. And then normal reaction force, normal reaction force, then tension, tension force, tension, friction, and remaining is external force. External force. Okay, so these are the forces involved in this chapter basically. So we have to remember these forces. So first is weight or gravitational force. Weight is basically considered as a W, and in that case we can say W equal to mg, or we can say also gravitational force Fg is equal to mg. And these forces, this force is always present in an object, and the force is always mg. Okay, so this is defined force. But in case of normal reaction force, so normal reaction force is involved when there is a surface present. So say there is a surface here, there is a surface here. In that case, either horizontal surface, or if you consider a inclined surface like that, or particularly like that, in that case, if there is an object in a surface, then the reaction force, normal reaction force, will act perpendicular to the surface. Okay, perpendicular to the surface, and here is also perpendicular to the surface. So normal reaction force is always perpendicular to the horizontal plane, and it's defined by n. Okay, and this normal reaction force has no particular value. It will vary with depending on the system, given system. Okay, so this is normal reaction force. And if you consider there is an object suspended, okay, so in that case there is no normal reaction force, because the object is in not, the object is not in a surface. Okay, so there is no contact with another object or another surface, so that's why we can say there is no normal reaction force. Now again, in case of tension, so in that case tension will present when we suspend a object, and it's defined by T. A suspended object, we by a string, or if we attach another object like that, say there is object here, and we attach a object with a string, and attach another object with a string. So this is a table. Okay, this is a table, and here is pulley. So in that case, the force away from the object, always away from the object to the suspended point. Okay, so this is tension T, and in that case we can say tension along the direction, say T1, and tension along the direction T2. Okay, and here is also T1 is upward, and here T1 is, T2 is upward. So from that drawing, we can say that same tension T1 for two objects, but the direction are different depending on the system basically. So here the suspended point for that object is basically along that direction. Basically the object, the tension will be away from that object, so outward direction, and here is also outward direction. And for that object, suspended point is upward, so that's why tension is upward. And here this T1, this T1 equal, and this T2 and T2 equal, but T1 is and T2 are not equal. If we consider the mass M1 and M2 are equal, then in that case T1 and T2 will be equal. So if M1 and M2 is equal, then we can say T1 and T2 are equal. But if there is a M1 is greater than M2, or we can say M2 is greater than M1, in that case there will be the tensions are different. T1 and T2 are different. So this is tension. Now friction is defined by F, okay, small f, and friction will present if the object will try to move through a surface or through another surface. In that case there is friction is involved if the surface is called frictional. Say there is an object here, or there is an object in inclined plane, just like that. Object, here is an object. So if the surface is frictional, then in that case friction is present. But if there is no friction involved, okay, so in that case you can say the surface is frictionless surface. So for frictionless surface, then frictional force is 0. Then if the object is moving rightward, v, then friction will be leftward. Okay, so basically friction of on an object acting opposite direction to the velocity of an object. Okay, so in that case, if the object is moving downward, then the friction will be upward. Or if we try to pull the object by applying force, so in that case the object is moving upward, then the friction will be downward. Okay, so these are the friction, and friction will depend on normal force by this equation. There is a relation between normal force and friction force by this equation. So we can say F equal to mu n. So F is equal to mu n. So here mu is coefficient of friction, which is constant for a particular frictional surface. So this mu mainly depends on the surface. So for a particular surface, mu is constant, and n is the normal reaction force. So you can find out the normal reaction force if the problem is given. Okay, so these are the mainly friction. And another thing is that friction is two type. One is static friction, and another is kinetic friction. So static friction involves when the object will remain stationary, but force is applied, and this friction will act until the object, not just until the velocity of the object will be zero, but when the object moves in a particular velocity, in that case the friction involved is called kinetic friction. Say in that object, if you consider there is an object here, so in this case, if we applied a force like that rightward direction, we applied a force rightward direction, F force. So if initially F force is say 2 Newton, so we applied 2 Newton force. So due to this application of the force, this object is not moving. Okay, the weight is very high. Uh, if we compare with the applied force, so in that case we can say the friction involved with this surface to the lower part of this box is static friction. And if we increase the say 12 Newton or 20 Newton, in that case the object will move at a certain velocity, say 2 meter per second. So in that case there is another friction involved, which friction is kinetic friction. Okay, okay, is it clear to you? Can you hear me? শুনতে পাচ্ছ আমাকে? Okay, so these are the mainly forces or explanation of the forces involved in Newton's second law. Okay, so now if we apply the particular forces in a particular problem, then you will get the answer. Say like that, the object is in a surface with making angle theta. Okay, and applied force is F. In that case, if the surface is frictional surface, then the process to draw the free body diagram is M. You have to follow the process. First you have to consider horizontal plane as a x-axis, vertical plane mainly perpendicular to the horizontal plane is y-axis, and you have to keep the object in the center. Okay, then you have to count the forces involved in that system. So first is normal force involved, what direction, weight is downward, W, and if we consider this angle is theta, then this angle is also theta, and applied force is F. If this angle is theta, we can say this angle is also theta. Okay, and there is a frictional force. Okay, due to this application of the force, we consider the acceleration of this force is upward, so that's why velocity is also upward, and we can say friction is downward, so that's why there is a friction which is F. Okay, okay, so this is the free body diagram, but this is not the complete form. Okay, if the forces produce a certain angle with axis, then in that case you have to draw the component. So along the x-axis is f cos theta, along the negative y-axis is f sin theta, and for weight, the components are in third quadrant, which is w cos theta downward, and along the negative x-axis, which is w sin theta. So this is the complete free body diagram. Okay. Now if we put the second law, we know that if net force along the x-axis is equal to max, and in that case we can say f cos theta is positive because it's working in the positive x-axis, and fk and w sin theta are negative because they are working in the negative x-axis. Then we can say m a, and here the acceleration along the x-axis is the total acceleration, and acceleration along the y-axis is 0 because there is no movement along the x-axis. Okay, so that's why acceleration along the y-axis is 0. So another thing is that you have to uh, write down the mainly sign of the acceleration also. If the acceleration is upward, then basically if the acceleration is positive x-axis, then the sign is positive, and if the acceleration is along the negative x-axis, in that case you have to write down the negative sign. Okay, so first we consider this acceleration is mainly positive. So if after calculating this equation acceleration is negative, then we can say the direction of the acceleration is reverse, but the magnitude of the acceleration is same. Okay, this is the x equation, and if we say along the y-axis, if net y is equal to may, so in that case net force along the y-axis is n minus f sin theta minus w cos theta is equal to ay is 0. So from that equation we can easily find out the normal force if the force and mass of the object is given. Okay, so this is the procedure to solve a problem. Okay, so I think if you practice the problem, uh, you can find out the mainly the procedure how can we solve the problems. Okay.